Hi, Algebra 1. So we have completely finished Chapter 1. So this is the time of the year where we would go ahead and take our review packet and do some review problems. So that's exactly what we are going to do with this video. But it's going to force you to pause and answer some questions. So we just have some examples. Let's go ahead, start with example 1. So 2 over 3 x plus 5 is equal to negative 4. Go ahead, hit pause and complete. Okay, let's go ahead. There's a few different ways that you could solve this. I like to fraction bust. So I'm going to multiply by 3. And I'm going to go through these pretty quickly because hopefully you already completed them. So 2x plus 15 equals negative 12. So when you take away 15 here, you get 2x is equal to a negative 27 divided by 2. And x is equal to negative 27 over 2. Can't reduce that guy. How'd you do? Pretty well? All right, let's try another one. Example 2. 1 over 3 times x plus 4 minus 5 over 6 x is equal to 1 over 9. All right, fraction busting time. I'm going to switch colors so that you can see here. If you're looking at 3, 6, and 9, you actually need to multiply this guy by 18 on that one. 18 is your LCD. So then we go ahead, we remind ourselves of that deal. So 18 divided by 3 is 6. 6 times 1 is 6. Times x plus 4. I didn't match my color. That's all right. 18 divided by 6 is 3. 3 times 5 is 15x. 18 divided by 9 is 2. 2 times 1 is 2. Now it's just a multi-step, meaning that we get to distribute. And then we're going to combine like terms. Use those inverse operations, so take away 24 from both sides, left with negative 22, divide by a negative 9. Now you can't reduce, however, it absolutely turns to a positive on that one. Okay, we had 5 sections, so you're going to have 5 examples. We're on example 3. So 2 times the absolute value of x minus 3 minus 5 is equal to 7. So we just learned these this week, and what we're talking about is that you wanted to isolate this x minus 3. So in order to do that, you have your inverse operations, and that's going to get you 12. Now divide by 2. The absolute value of x minus 3 is equal to 6. If you got to that part, you're on the right track, because now you need to set up 2 equations, one with a positive answer, one with a negative answer, and then use inverse operations. So x is equal to 9, or x is equal to negative 3. Let's get, we use this color red. All right, example 4. Negative 2 plus 5x minus 7 is equal to 3x minus 9 plus 2x. All right, multi-step, so we're going to go ahead, we're going to combine like terms. I want to combine this negative 2 and negative 7, leaving me with 5x minus 9. And on the other side, I have this positive 3x and a positive 2x for 5x minus 9. And at this point, you're saying, whoa, it's the same on both sides. We can go ahead and we can call this an identity, also known as infinite solutions. But let's prove it to ourselves. I'm going to go ahead, I'm going to take away negative 5x from both sides, leaving me with a negative 9 is equal to negative 9. I for sure know that. Infinite solutions for that one. Did you get it? All right. Our last one, you might know what it is. It's section 1.5. It's a literal equation. So 2y plus 8m over a is equal to 2p. And I'm going to ask you to solve for y. All right, I want to multiply by a to cancel out on this side, but if you multiply by a on that side, you have to multiply by a. So we're left with 2y plus 8m is equal to 2, and I like to put these in alphabetical order, AP, but maybe you put PA on that one. Now I'm getting y by itself, so I want to take away this 8m from both sides, leaving me with 2y is equal to 2ap minus 8m. Very last step is to divide by 2. Now, just like if you were multiplying, you would have to divide everything by 2. So y is equal to, this reduces ap minus 4m. So y equals AP minus 4m. And that is it for chapter 1.